Hello class and welcome. In this lesson, solving linear inequalities, you will learn to solve a linear inequality with one variable. Now before we go into this, let's talk about the interval notation. Recall what an interval notation is, because we're going to write our answers in interval notation. Now, it's another way of expressing the answer to an inequality. Now we use one of two things, parentheses or brackets, depending on where the graph is going to be an open or closed situation. Now, we use parentheses when we do not include the endpoints, and that occurs with inequalities that are strictly greater than or less than a value. That's when we use these parentheses here. Now, if the inequality that we're using has an equal sign underneath it, so like greater than or equal to, like in this example here, how do I make this line? Greater than or equal to, or less than or equal to, that's when we use the brackets on those endpoints. Now, what always uses the parentheses are the infinities. A parenthesis is always used with the infinities. I misspelled parenthesis. And this is new. Only for inequalities, this is going to be really important here, that when we multiply or divide by a negative number, we have to switch the direction of the inequality if you end up multiplying or divide by a negative number. Now, when I say switch, I'm referring to like switching the greater than to less than, like switching in these direction from left to right, right to left, and the same thing over here, left to right, right to left. I do not mean to switch from a less than to one that has an equal sign underneath it. And the same thing with the greater than. I don't mean to get the greater than and switch it to the one that has the equal sign underneath it. No, it means to switch the direction from greater to less, or vice versa, from less to greater. So let's look at some examples of this. So on the first example, we want to solve this inequality. We'll start by following the same rules as an equation by distributing and multiplying everything by in the parentheses by 4. So we have 4x plus 12 is greater than negative 24. Now, the same rules apply with any equation. We want our variables on the left side and our numbers on the right side. So I need to move this positive 12 to the other side. So we have 4x greater than the negative 24, and by moving the 12 to the other side, it's going to end up subtracting it. So we're going to subtract 12. So 4x on the left greater than, and negative 24 minus 12, that's equal to a total of negative 36. We are now going to divide by 4. So the negative 36 gets divided by this 4 over here. So we're going to divide by this 4 there. And we're going to get the following. We're going to get that x is greater than negative 9. Notice that our answer is negative, but we did not switch the inequality. Again, the new rule is that we switch the inequality only if we are multiplying, or in this case, dividing by a negative number. And we're not. We're dividing by a positive number, so the inequality is going to stay in the same direction. So now let's represent the solution on the number line. So we'll start by putting the negative 9 in the middle, and again, negative 8, 7, 6 will be on the right, and the smaller numbers will be on the left. So we have negative infinity on the left, positive infinity on the right. Now, because this inequality does not have an equal sign, that means that the circle above the 9 is going to be an open circle. And since we're looking for the values that are greater than, that's going to be the values to the right of negative 9. So the graph, the solution as a graph would look like this. Now, in interval notation, our interval, again, will start at the endpoint of negative 9, and since it's pointing to the right, we will end to positive infinity. Now, with the infinity, again, we always use parentheses. As I wrote up here, we always use parentheses with the infinities, whether positive or negative infinity. We always use parentheses. Now, with the 9, because the 9 is open, we're going to use again that parentheses on that endpoint. So we're going to put parentheses on that endpoint, and that's our solution. Let's look at the next example. On example number 2, we'll start by first getting rid of the parentheses by multiplying the 3 into those parentheses. So we have this x that we're going to bring down. We're going to multiply that negative 3 into the parentheses, so that's negative 3x minus 6 is greater than 4. We need to move this number to the opposite side. So that's going to move over here, making it negative 6. So we have our greater than symbol. We're going to bring down the 4, but since the 6 needs to be moved to the other side, that becomes positive 6. Now let's simplify. On the left, we have 1x minus 3, which is negative 2x, greater than. And on the right, we have 4 plus 6, which is 10. We are now going to divide by a negative 2. Okay, that's very important. We are dividing by a negative 2. So since we're dividing by negative 2, that's going to give us negative 5. So we have x and negative 5. Now, this is very important. Since we're dividing by a negative, the inequality is going to switch directions. So instead of pointing to the right, saying greater than, it is now going to point to the left, which is now less than. So let me write that over here. So x is less than negative 5. Less than negative 5. So that's our solution. Okay, this is our solution right here. X is less than negative 5. And again, the reason that this happened is because we are dividing again by a negative. So we have to switch the inequality from greater than to less than because we are dividing by a negative. So let's graph this solution on the number line. So we're going to put the negative 5 right here in the middle. Because it is not equal, no equal sign underneath it, we're going to use an open circle, and the arrow is pointing to the left. Less than are the numbers to the left of the value. So remember, my greater than numbers are always to the right, and my less than numbers are to the left, towards negative infinity. So now our interval is going to be the following. Because we're going from negative infinity to negative 5, we're going to write our interval in that order, negative infinity to negative 5. And again, just like on the previous example, we're going to use parentheses because we have an open circle above negative 5. We're not including it. All right, let's move on to example number 3. So just like number 2, we're going to start by, again, getting rid of the parentheses. So we're going to distribute and multiply the parentheses by negative 2. So we'll bring down the 7x for right now, multiply the x by negative 2, which is negative 2x, multiply the negative 4 by negative 2, which is positive 8. And that is less than or equal to negative 2. Now we're going to move letters to the left, numbers to the right. So the 7x and the minus 2x are on the left side of this inequality already. So we're going to keep them the same sign. So they do not change. They stay positive, 7 and minus 2x. However, the 8 does need to be moved to the other side, and that's going to change it from a positive 8 to a negative 8. Now 7 minus 2, that's 5, and negative 2 minus 8 is negative 10. Now pay very close attention to this. We're going to divide by a positive 5 this time. So pay very close attention to that. This number that we're dividing, again, is that number right here that I've highlighted in blue. So we're dividing by a positive 5. So since we're dividing by a positive 5, that does not switch the inequality. Let me erase this. That does not switch the inequality. Still has it facing to the right. So still greater than. Negative 10 divided by 5 is in fact still a negative number. It is negative 2. But just because the answer is negative doesn't mean that the inequality switches direction. Only if I am dividing by a negative number, and in this example I'm not. So our solution, let me write it over here on the right side, is that x is less than or equal to -2. I said greater than earlier. I meant less than or equal to. So this symbol here, let me write what this means. This is less than or equal to. Okay? So is less than or equal to. This one is less than. Let me go back over here. This right here is greater than. Okay? So back to this example. So this one is less than or equal to. So let's graph this on a number line. So we're going to put our -2 anywhere on the number line. We'll put it right there in the middle. Because of the equal sign, this time our circle is going to be a closed circle. And just like the previous example, example number 2, it's less than. So that's going to be pointing towards -infinity. And you can kind of see, look at this. Just to make this correlation. You see how this arrow in purple, again, is pointing towards the left, just like the inequality right here. As long as you follow, again, my directive and do it this way, where you have the letter on the left and the number on the right, this inequality is going to tell you in which direction you have to make your arrow or your line towards and which infinity you have to point to. So right here, we're going to point towards -infinity. So our interval would be from -infinity. Let me do it in black. From -infinity to -2, but this time it's going to be a closed bracket. So bracket because of the closed circle. Okay, let's do some more examples. Now, for an example like number 4, just like anything, we have to get rid of that denominator. Like examples, we've done this before. Now, if you recall, the way that we get rid of this denominator when one side is being divided by a value is that we cross multiply. So we're going to multiply all of this by -2. So we have the 4 plus 5 times 2w minus 10. Let's keep that right now the same. And we're going to multiply, let me just say this one more time. We're going to multiply all of this by -2. Now again, just like the rule stated right here, because we're multiplying by a negative number, we have to switch the inequalities. So since I'm multiplying -2, I have to switch this inequality. So the inequality is going to change direction, and it is now going to be greater than instead of less than. And that again is because we're multiplying by -2. So -2 times w is -2w, and 7 times -2 is -14. So in this situation, we do the switch at the very beginning and at the very end, because at the very beginning we had to multiply by -2. Okay, now we can continue solving the inequality by following the same rules as before. We're going to start by distributing. So we have 4 plus 10w minus 50 is greater than -2w minus 14. And now we're going to put all our variables. Let me highlight all of my variables in blue. I want all of these numbers to be on the left side of this purple inequality symbol here. And all my numbers, all my constants, those green numbers to be on the right side of that purple inequality. So since 10 is already on the right side, that's not going to switch sign. That's going to stay as positive 10. However, the 2 needs to be moved over. So that's going to be positive 2w. The 4 along with the 50 need to be moved over. So that's going to change the sign. So the 14 is good. 14 is already on the right side of this purple inequality, so it's going to stay as -14. However, the 4 is going to change to -4, and the 50 is going to change to positive 50. The left side simplifies to 12, and the right side is going to simplify to 32. So now this 32, let me write it here. This 32 will be divided by this positive 12. So our inequality is not going to switch direction. Let me put it over here. So our W is going to be, the 12W is not going to be just 12, just 12. Our inequality is still going to be pointing towards the right, greater than. And 32 divided by 12, well, that's going to give us a decimal of 2.66666, but we're going to convert that into a fraction. And let me show you how to do that with the 84. Hold on, give me a second. Let me do the slide over. There we go. Okay, so let me clear this. And we're doing 32 divided by 12, which I told you again is equal to that value there. Now, if you're using, again, the yellow calculators, the 84s, the way to convert this answer into a fraction is that we're going to click on the, let me move it over here. We're going to click on this math key right here. You see that it turned yellow, white, this math key, and we're going to select the first option, the one that says fraction. So we're going to hit 1. Oops, too many times. Let me delete those. And we're going to convert our 32 divided by 12 into a fraction, which, as you can see, is a fraction 8 over 3. So this 32 over 12 is the fraction of 8 over 3. So as a number line, we're going to put 8 over 3 here in the middle. Since we're drawing it ourselves, no equal sign. This symbol here is the is greater than symbol, not equal. So that means that the circle above the 8 over 3 is going to be an open circle and pointing towards the right, towards positive infinity. So our interval would be this. All right, let's do a couple more examples, okay? Let's look at example number 1. In example number 1, we're going to distribute, but the number in front of the parentheses is a 1. So let's bring down the 3, and let's distribute this 1x into the parentheses. So that's going to be negative 2x plus 7 less than or equal 34 minus 6x. Now we're going to, let me highlight our stuff. So our variables on the right side of this purple inequality, and our numbers, our constants in green on the right. So let's see what we have. Well, negative 2x is already on the right of the purple inequality. However, the 6 needs to be moved over. So that's going to make it positive 6. The 3 needs to be moved over along with the 7. So the 34 is good. It's already on the right side of the inequality. But the 3 is going to become negative, and the 7 is going to become negative. So let's see here. Let's simplify the left side. So negative 2 plus 6 is 4. So we have 4x less than or equal to. And then 34 minus 3 minus 7. 34 minus 3 minus 7. That's a total of 24. Now we're going to divide. But we're dividing by a positive 4. So again, we're dividing by a positive 4. So the inequality is not going to switch. So we're still going to have x less than or equal to, and well, 24 divided by 4, that's a total of 6. So this is our solution. X is less than or equal to 6. And this symbol right there, again, is the is less than, I don't know why I'm writing greater than, sorry. less than or equal to. So on the number line, we'll have a closed circle above 6 pointing towards the left, towards negative infinity, and our interval will be negative infinity to 6 with a closed bracket on the 6. Okay, now let's look at the last 3 examples. So for this example, no distribution, nothing like that. We can automatically go straight into having our letters on the left side and our numbers on the right to this inequality. So 5v is already on the left side of the purple inequality. The 7 needs to move over, so that's going to change to negative 7. And the 1 needs to be moved over, changing it to a minus 1. The negative 17 is going to stay as negative because you're not going to move that to the other side. Now 5 minus negative 7, that's negative 2v. And negative 17 minus 1 is negative 18. We're going to divide now by negative 2. Okay, notice that this number is negative, so we're going to divide by negative 2. So because of that, our inequality is going to switch from greater to less than. So v is going to be less than negative 18 divided by negative 2, which is positive 9. So this is our solution. V is less than 9. So is less than 9. So on the number line, we'll have 9 somewhere on the number line. An open circle, less than will be pointing towards negative infinity. So our intervals from negative infinity to positive 9, open with negative 9. And then finally, for the last 2 examples, there are 2 very special cases. And let's discuss what's going to happen there. And this one, before we actually do them, what's going to happen here is that the x's on the left side are going to end up canceling each other out. They're going to end up equaling to 0. So let's see what happens when that occurs. One of 2 things is going to occur. We're going to either end up with a true statement that 0 is going to be smaller or bigger than the number on the right, or it's going to be a false statement where 0 is not going to be bigger than or less than the number on the right. And each situation gives you a different solution. So on this example, on number 7, let me zoom in. We're going to start by distributing. And we'll multiply 8x minus 9 with 3. So we have 24x minus 27 is greater than, and we'll distribute on the right side, 24x plus 4. Now, as before, we want our variables, our variables on the left side and our constants, which are in green, on the right side of this inequality. So let's move things around. So 24 is going to stay on the left side. This 24 is going to move to the other side, making it negative 24x. Our inequality is going to still stay right here. And then the 27 is going to move to the other side. So this 4 stays positive, but this 27 changes from minus to positive to plus. And now look what happens. 24 minus 24, that's equal to 0. So we end up with 0x, or simply 0. Less than, and 4 plus 27, well, that's equal to 31. Well, this is not true. 0 is not greater than than 31. 0 is not greater than. That symbol is greater than, so this ends up being false. And because this is false, because this is a false statement, what that means about the answer is that there is no solution. So there's no solution to graph. We cannot graph this solution. So as an interval, also the same thing. We cannot write an interval because, again, there is no solution. So this is one thing that could occur when we eliminate the x's or the variable on both sides. Like in this example, we end up with something that is false. And when it's a false statement, there is no solution. Now let's look at the second example. What happens when we have the left side equal to 0, when the variables cancel themselves out? So look at number 8. So we'll start by again distributing the negative 1 into this parentheses. On the right we have 11x minus 4 is less than or equal to 6x. Let's distribute again that negative 1, so that's going to become negative 3. Negative 1 times negative 5 is positive 5, so positive 5x. And we put again our variables on the left side and our constants on the right side of this inequality. So we have 11x. This is going to move to the left side, making it minus 6x. And this is also going to move to the left side, making it 5x. Less than or equal to. The negative 3x is going to it's already on the right side of the inequality, so that's going to stay the same. But we need to move the 4 to the opposite side, making it plus 4. So we have 11 minus 6 is 5, and 5 minus 5 is 0. So again, we end up with 0 on the left side. 0x, which is just 0. And negative 3 plus 4, that's 1. Well, this is in fact true. 0 is in fact smaller than, is less than or equal. Okay, it is in fact true that 0 is less than 1. Obviously not equal to 1, but again the key word right here is or. So it has to be one of the two things has to be true, and this is true. 0 is less than 1. So in this situation, because this is a true statement, when we eliminate the x's, we end up with 0 on the left. What that means in terms of what the solution is that the solution is infinitely many solutions. So we're not going to draw we're not going to actually label the values underneath here, but this is going to be from negative infinity to positive infinity. So from negative to positive infinity. Okay. So our interval is all real numbers. And that's the difference again between a situation where our x's become 0 on the left side, that we could either end up that 0 is going to be, that 0 is in fact going to be bigger than or smaller than the number on the right, or is not. Like in the first example, number 7, it is not true that 0 is bigger than 37. Had it been the other way around, had this inequality been pointing to the left and we're saying that 0 is less than 31, then in that situation, this example 7 would have the same answer as 8. And the answer would be from negative infinity to positive infinity. Okay, so as long as 0 is in fact bigger than or or smaller than the number on the right, then your answer is going to be negative to positive infinity. That's going to be your answer. But if it's not true, like a number 7, and 0 is not in fact bigger than or less than 31, or the value or whatever number this is, then the answer is going to be no solution. So like on this example up here, had it been 0, but instead of saying less than 1, had the inequality been pointing to the right and saying greater than 1, and we were comparing this, sorry about that, had we been comparing this, like I was saying, this is false. 0 is not bigger than 1. So this would have been, again, no solution. So that's, again, how you determine whether we have no solution or infinitely many solutions, negative infinity to positive infinity, in those situations where you end up with a 0 on the right side when you move your variables to that side right there. Okay. All right, that concludes the examples on solving linear inequalities with one variables. If you have any questions, please send me a message through email. I appreciate you watching, and like always, I hope you have a great day. Goodbye.